Oh, yeah. Excellent. So, the topic for this talk is web application security, and particularly the weird parts, which, when we're talking about front-end security, basically means browser quirks. So, things that web browsers do that you might not expect, might be against the spec, or the spec might be weird, but nevertheless you should know about and you should care about. My name is Juho Nurminen. I've been doing web application security professionally for about 3 years, a bit more than that actually. And before that I was actually working at Vaadin as a Vaadin developer. So, starting with a sort of obvious thing that probably everyone who's done web development is in some way familiar with, HTTP cookies. They are a weird thing because they're sort of a legacy technology. They've been around forever and they don't really play well together with any other web technologies. Mainly because of the HTTP cookie scoping, which is something else. The particular issue there is that HTTP cookie scope is not related to the same origin policy in any way. Those two just don't mix really well. The same origin policy is a really simple security policy that's in effect in all web browsers, and you probably know about, even if you don't sort of acknowledge it consciously. The same origin policy says that you can't access another website if it has a different protocol in the URL or a different domain or a different port. Cookies are different. They don't respect the same origin policy. So you can share cookies between different websites and between different origins. Cookie scope is configurable, and there's a whole bunch of things you can configure. The first 4 of those are probably the ones you've used if you've used cookies or had to deal with cookies. Then there's 3 fairly new ones that are security related and are actually smart, but yeah. And different scopes can overlap, so you can have 2 websites that, for example, you have a website on a subdomain, and then you have another website on another subdomain, and the other one is scoped to the parent domain, so that the one website's cookies are being passed to the other, but the other website's cookies are not being passed to the first one. So it's a bit weird. And also regarding the configuration, you can't actually use the ones that are really useful. So, so basically, these 3 ones aren't supported in all browsers. None of them are supported in Edge or Internet Explorer, and same-site cookies aren't supported even in Firefox. That's coming, but it's not quite there yet. And this is basically what cookies look like. On the left there, you have your website, whatever, web server, cloud, whatever. On the right, you have the client, or sorry, my left, your right. And your website sets a cookie. It sends a cookie over HTTPS to the client. The client sees the cookie and looks at it, looks at the cookie header and sees that there's no flag set on that cookie, so it's okay to pass it over to HTTP and send it over there. And then there's a man in the middle in the HTTP, and the man in the middle reads the cookie. And if you're storing session identifiers in the cookie, well, you just gave your sessions away to whoever's in the middle listening to your HTTP connections. This one is a solved problem, so you can actually do something about this, and what you can do is set the secure flag. So basically, on the server side, you have to mark your cookies as secure, after which they won't be passed to the HTTP connection at all. the client sees the secure flag and decides that, okay, it's not okay to send this over HTTP. But that's not the only issue, because the man in the middle is still there in the HTTP connection. And what the man in the middle can do is they can set their own malicious cookie. That's a bad cookie. You wouldn't eat that. And the client will take that cookie, they will read it, and they will see that there's no flags on it. It's a cookie, and it's coming from a valid source, which is your website, except there's a man in the middle. And the client will send it over to the HTTPS connection, and they will overwrite the HTTPS cookie. And then you'll have the attacker session in your HTTPS connection, even though your HTTPS connection is perfectly secure and no one can read anything from it. But the attacker can set cookies over there. There is a mitigation for this as well, which is called strict secure cookies, which is just an addition to the original cookie RFC. And you don't have to do anything to use strict secure cookies. But again, that one's not implemented in all browsers. So Internet Explorer doesn't support it, Edge doesn't support it. So basically, you're screwed if you're using cookies. The only thing you can really do that has an effect for all clients is you can completely get rid of the HTTP connection. And it's not enough to just close the port on your server and say that, okay, we don't accept HTTP connections, because the man in the middle can still say that, okay, I'm the server. Even though there's no real server, the man in the middle can just hijack the connection and say, I'm the server, send your data to me. But what you can do is you can use HTTP strict transport security and HSTS preloading, which basically tells your client that, okay, this website has registered as a website that only supports HTTPS, and you can't connect to this website over HTTP. And so when the client knows beforehand that they can't connect to a website over HTTP, then they will only connect to it over HTTPS, and you completely get rid of the man in the middle. But that's a sort of a workaround solution, because it's not related to cookies anyway. And if you need the HTTP connection for something, then basically you have to accept the risk, which is a terrible way of saying not fixing things. There's another major issue with HTTP, HTTP cookies. Who can tell me what's happening here? Any ideas? This is a JavaScript code that's running on GitHub pages. Why is this terrible? Basically, what's happening here is it's setting a cookie on GitHub pages and it's scoping it to the parent domain, which is github.io, and then it's setting the cookie on all GitHub pages simultaneously. Except this doesn't actually happen. There's a mitigation for this as well, only it's a sort of lesser known mitigation. There's a website called publicsuffix.org where you can submit your own second level domain or third level domain or whatever and tell them that this is a suffix and you shouldn't set anything on this. This is basically a TLD. You can't use this for anything useful. And that will tell the browsers use the list that's available at publicsuffix.org, and they will check it and they will see that, okay, I can't set a cookie on the second level domain at github.io. And that's why you can't do this on github.io. But if you're hosting untrusted content on your own subdomain, this might be an issue. Or if you, for example, have a website on www.yourdomain.com, and then you have an API on api.yourdomain.com, and then the API has a vulnerability that allows you to inject HTTP headers or whatever, the attacker can potentially bounce to your web application domain through that. So it's definitely something to consider. And if you're not hosting content on your second level domain, you might want to submit it to publicsuffix.org. Moving on from HTTP cookies to URL parsing. This is another weird thing. It's sort of my favorite thing about web security because it's such a simple thing, or at least seemingly simple thing. URLs are fairly well understood, and everyone knows how URLs work, and everyone thinks they can parse URLs correctly. That's usually not the case. There's way too many different parsers, and there's way too many different things that are slightly ambiguous in the spec, and there's way too many places where you can go wrong. So here's a piece of JavaScript code. Client-side JavaScript code, a function that takes as a parameter a URL. The target parameter is a URL, and it's supposed to validate the URL and check that it's not pointing to an external domain. And if it's pointing to the same domain the script is hosted on, then it allows this redirection to be done and sends the user that way. But this is horribly broken. Any ideas why? Guesses? Or if you can't guess, can you point to the line that's obviously terrible and dangerous? There's something that's a red flag when I do a penetration test or a security test. There's a single line here that, yes.
The third line.
The a.href. No, that's perfectly okay. It's the second to last line. That's one. When I see that in JavaScript code, I immediately start looking at where is the input coming from, because location.href is basically an XSS vector. So you can trigger JavaScript execution through location.href if you pass it a JavaScript URI. So if a.pathname starts with JavaScript :something, then it will execute the stuff that comes after the colon. But, yeah, so dangerous assignment. But the thing is, there is validation, and it's doing sort of the right thing. What's happening here is it's taking the target parameter, it's passing it to an A element, and the A element is basically parsing the URI using the DOM, and then we're fetching the host name and comparing it to the current host name. And if it doesn't match, then we throw an error and don't do the redirection. The issue here is Internet Explorer, basically. Internet Explorer has this weird bug or feature, or I don't know what they call it. But basically the issue here is all other browsers, when you access this a.pathname property, they will return / your path. Internet Explorer doesn't return the /, they only return your path without the /, the initial /, which means you can't, if you pass as the target URI, you pass http yourdomain.com /javascript : something, then it will validate the domain, it will check, okay, it's your domain, then it will take the path and pass it to location.href, and it will execute the JavaScript, which is cross-site scripting. Meaning this happens. Here's a fix. Is this any better? That's the only thing that changed. So now we're checking that, okay, if it doesn't start with a /, then we prepend a / to it. Well, this is still broken because you can't execute JavaScript anymore, but you can basically bypass the whole thing that this thing is trying to check. So it's trying to make sure that it won't redirect to an external host. And if you start with 2 slashes, then it will be a protocol relative URL, and it will redirect to an external host. So basically what you would pass to this function in this case would be http yourdomain.com /evildomain.com / whatever. and then it would redirect to that evil domain, because it's not taking the entire URI that's coming originally from there, it's taking only the path name, and the path name starts with 2 slashes, and that's no longer a path name, it's a protocol relative URI. Same thing, but on the server side. PHP. How many of you like PHP? Excellent. Who can tell me what's wrong with this? Yeah, that's true. No, that's actually not true. PHP is doing everything perfectly here. PHP is not to blame in this one. It's something entirely different.
Header.
What about it?
We said, I mean, we're pretty much doing the same thing we did in the previous case, except for we don't do this validation that we do last time.
We're doing the validation there. The URL is coming from a get parameter, and then we're parsing the URL, comparing the host name to the server name, which is basically the host name. And then we're parsing it. If the host name matches, then we're parsing it to the location header, and PHP additionally automatically makes it a 302 redirection. The issue here is PHP parse URL is not the only parser that's involved here. There's another one that's not visible in this code, because the browser also has to parse the URL from the location header. And the browser has its own URL parser that's different from the PHP parse URL function. And they parse the URLs differently. So basically, you can create a URL that's perfectly valid when PHP looks at it, and it's perfectly valid when the browser looks at it, but the domain that PHP sees is different than the domain that the browser sees. And the way you do that is you pass it something like http://evildomain.com/ at yourdomain.com/. And PHP looks at the backslash and sees that, okay, that's just a backslash. It's not a special character, it's just a regular character. Backslashes don't mean anything in URLs. Backslashes are a Windows path thing. They don't mean anything. But the browser looks at the backslash and decides, okay, the user probably meant /. And then, then they parse it as a /, and then they decided, okay, evil.com is the domain name, even though evil.com in this parsing instance was actually the username that's passed as HTTP basic authentication. So whenever you see two different parsers parsing the same thing in separate places and you expect the same results, your expectation is probably wrong. RFD. Has anyone heard about reflected file downloads? This is a vulnerability type, sort of like XSS or SQL injection or whatever. Has anyone heard of this? No one, okay. Not surprising. This is actually a fairly new technique. This was introduced in 2014, I think, in Black Hat USA initially. And this is basically how it works. You have an API, you do a GET request, you search for cat GIFs, and you return an HTTP response that contains JSON, and there's the query that's parsed cat GIFs, and then there's results that's just a list of cat pictures. Where it goes wrong, though, is when you're able to append stuff to the path. And this is not an unusual case that you're able to append things to the path without the API caring. For example, PHP does this. PHP in its default configuration, if you just have scripts in the web root, it will just ignore everything that comes after the script name. And that's what's happening in this case. So we're appending /setup.bat, and the response is still completely the same. Step 2, we inject the payload. So we change the query we're doing, and the query is being reflected to the response. It's still being parsed as usual, but there's no spaces, so it's just one string, and it's being escaped properly, so it's completely valid JSON. No issue there, except, well, RFD, but yeah. This still looks like it couldn't harm anyone, right? Like there's no cross-site scripting or anything. It's plain text, so you can't script it. You can't do anything malicious, really. Except you don't have to do anything other than that. And when you open it in a browser, this happens. Do you want to download setup.bat? And if you click run, it runs and pops Windows calculator. And the way it works is, if you look at the previous, this line here is actually a valid batch script, Windows batch script. And it is a valid batch script because batch scripts don't use backslashes for escaping. And so it sees a bunch of strings and then 2 pipes, which is an OR operator, and then it sees calc. It says, okay, there's some stuff I don't understand, and if I don't understand it, then I'm supposed to run the next thing, and then if I don't understand that, then I'm supposed to run the next thing. And it takes the first part, sees that, okay, this doesn't make sense, I'll just throw it away, and then it sees calc, and then it runs it, and then you're pwned, basically. So the way you would want to fix this is instead of content disposition attachment, you would do content disposition attachment semicolon file name equals response.json or something, so that the browser won't take the file name from the path, and instead it will take the file name from the response header. And that way you won't get it back as a batch script, and you will always get it back as a JSON document. That's basically everything I had. I had more stuff, but I thought my time would be more limited. I guess I have a few minutes still left. Here's some further reading if you're interested in web application security, especially on the front end. MDN Web Docs has an excellent section on web security. There's the html5sec.org page, which is basically a collection of ways to cheat browsers out of encoding and escaping things. And then there's Oren Hafif's original RFD white paper, which is what we just saw demonstrated there. He's describing there the fine points of that attack. Elkamtuf's post-XSS attacks, basically things that you can still do in a web application if there's, for example, a browser filtering the results so that you won't be able to do reflected XSS. There's things like content exfiltration without running scripts. And Elkamtuf's The Tangled Web, which is an excellent book. I recommend that to everybody who works with web applications. It's basically a reference of everything you should do to make your application secure. So it's worth a read, definitely. That's it. I have time for questions if questions? Yeah.
Any weird parts related to the authorization error, because that's often used with the APIs instead of cookies?
Not much, no. At least I haven't seen any weird interactions. I mean, it's not a particularly special header. The only part where it's used by default by browsers is if you do HTTP basic authentication. And that usually doesn't interact with anything. So authorization headers are usually okay, but I would maybe prefer using something with X- prefixes, because those definitely won't be caught by the browser end. processed in any way. So maybe using authorization headers for the initial handshake sort of, and then sending back a session token that you pass in x dash something. Anyone else? Yeah?
About the domain that protects against cookies, like on
Yeah.
other domains, how do browsers interact with it? Like, could an attacker like intercept that communication?
No, they don't communicate with the website in any way. It's baked in. So sort of like HSTS preloading. It's a list that they update whenever they update the browser version.
Yeah, that was my question. So how often do they update it?
Probably every time there's updates to the list and every time a browser version comes out. But I don't really know, probably browser dependent as well. But I would assume that every time the list updates, the next browser version will contain the updated list. It's not a high volume list because, well, most people don't submit their domains to that because it really limits what you can do with your domain. Anyone else? If not, thank you very much. That's it.